Here's a big 10-mark graph question. Right, first thing, you want to find f of 3. So you need to understand what the graph shows. F of 3 is the value of y when x equals 3. This does come up from time to time. So what's the value of y when x equals 3? Well, it's that. And judging by the scale, that looks to me like it's 2. So we just go to when x is 3 and we find out, because y equals f of x. So f of 3 is what the function does to 3 when you put it in as x, and what you get out is 2. It then says solve f of x equals 6. So when does this graph have a value of 6? Well, if I draw a line across, when x equals 6, it's a thick line, so it's not entirely obvious, but it looks like it goes through at -1. I think it goes above this. I think this peaks at 5. I'm not sure. It could be that it peaks as well at 2. There is a 2-mark question. I think that's because you need to draw in the line at 6 to show you know what you're doing. So I'm just going to go with -1. So I go with 2 as well. I think maybe it could go through 2, but it's hard to tell from these diagrams. Let's say 2. It could go through 3 times potentially if this horizontal line at 6 were a little bit lower. But anyway, it's basically where the graph goes through y equals 6. Right, f of 1. Now this is a very tricky question. It's asking you to find out what f of 1 is. So it's just like when you have a normal function question. The first thing you do is work out f of 1, and then you work out the f of that. Well, how do we work out f of 1 from a graph? Well, we go across to 1, we go up, and we see how high it is above y, and it looks like it's 5. So actually that line is a bit higher. So anyway, sorry. Let's not go back to the first part. F of 1, you go to 1, you go up and you see how high it is, and it looks like that value is 5. So f of 1 is 5. So then we need to work out f of 5. It's not on the graph, so I'm going to, okay. Maybe I should have had a look at this question before I went through it. Okay. F of 1 can't be 5, because otherwise this question wouldn't work. So I'm going to assume that it's difficult to read this graph. It looks like, we'll say it's 4. Okay. I think it probably is 4. So if f of 1 is 4, then we now need to work out what f of 4 is, because we're doing f of 1. So now we go to 4, we go and see what the y value of 4 is, and take a guess again. I think that looks like -13. That's the answer. So apologies for the really haphazard way I approached that question. Let's just run through the logic again. If we get rid of some stuff, that would be helpful. Okay, f of 1. So to find f of 1, you're looking for the y value you get out. Well, f of 1 is the same as f of brackets f of 1. So to find this value, we look at what you get out when you put 1 in. If you go to 1, what you get is a height of 4. So then we're looking at what happens when you f4. So if we put 4 in, what do we get out? It's this value, and that looks like -13, and that's why f of 1 is -13. It's a tricky question. Find an estimate for the gradient of the curve at the point where x equals -1. Well, to find the gradient of the curve at -1, we need to go to -1, and we look at this section of the line, and we imagine that that bit of the line here is turned into a straight line. So if it were, it would look something like that. It's hard to draw accurately, but never mind. And then all we need to do is, once we draw in this line, which is a tangent to the curve at -1, we then pick 2 points, preferably points which are far away from each other, and we work out what's happened in between. So between these 2 points, what's the rise, what's the run? Well, the run is how far you go across left to right. So the run is 3. And the rise, careful here, how far we go up or down as we go from left to right. Well, it starts off at about, 15, and goes down, or 16, and goes down to about, I meant here, sorry. Oops. That's the point we were looking at, wasn't it? So that's the point we've got to cross by 3. And it looks like we started about sort of 15, 16. Again, it's very difficult to tell on the computer. And it's gone down to about -15 or 16 over the space of 3. So let's read, we've gone down 30. Space of 3. So that would mean that if we've gone down 30, if we're going 3 across, that would be a gradient of rise over run. Get 1 mark for drawing the tangent. We get 1 mark for writing out how we calculate the gradient, which is -30 over 3. imagine if you wrote positive 30, you lose a mark. So the gradient is minus 10. Then we get to this last question. The equation f of x equals k, where k is a number, has three solutions between x equals minus 2 and x equals 4. So between f of x equals k has three solutions between negative 2 and x equals 4. I'm actually going to have to think about this one for a bit. When we're looking for x equals k, what we're trying to say is, well, when you solved f of x equals 6, you drew a horizontal line across, yeah? So when you have f of x equals k, it's the same thing. You've got a horizontal line value k. So here k is 10. Before when k was 6, it was here. Here it could be f of x equals 20. Here f of x equals minus 22. So the height of this bar is f of x. Now it says it has three solutions. If I highlight that bit there. So where does this line go through the graph three times? Well, it goes through between here and here. The confusing bit, I suppose, is the bit where it says between x equals minus 2 and 4. The reason it says that is because you can't see the rest of the graph. So you have no idea where else this line could cut through the line at points over to the left and over to the right. You know, the curve could bounce up or down again. So we're solely interested in this range and, or this domain, I should say, because it's the x values that are limiting the width. But there. So within the bit we can see here, how many times does this horizontal line, f of x equals k, what values of k does it have three solutions for? You can see that it's going through once, it's going through once, it's going through once, it's touching here, it's going through twice. And this narrow range, it can go through three times, and then it goes down to once after that. So the lowest value that k can have for it to go through three times, well, it looks like it starts upwards of 2. And the highest value, it looks like, I'm going to try and work this out. So hard to tell. I think it's between 2 and 6. You'd probably have a better idea. But within that range of k, this horizontal line cuts through our graph three times. So that the set of values between 2 and 6, that's the set of values for which this cuts through three times, which actually sort of solves the first part of the question when we were talking about f of x being equal to 6. If this value is 6, then that's one of the solutions for f of x equals 6. But anyway, difficult question. I hope I explained it well enough. Again, please email me if you're not sure.